Bismillah, Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. Okay, in this video I'm going to show how to simulate a cyclone separator using CFDSOF. Well, okay, let's start first from how the simulation should be. So this is the simulation. I'm sorry. So this is the result of the simulation. So I I will only give you how to set the simulation setting, but I think I'm not gonna finish the simulation until the end because it will takes a longer time, a very long time. So I just show you in this video the result of the simulation. Oh, sorry. I'm also apologize for my very bad English, but I think I hope that you can learn as much as you can from this video. So let's see the result of the simulation first. Here is the result. So we see that there is a amount of particles that it's injected from the inlet here, and then the particles will go down and separate it from the fluid, right? So now we open the CFDSOF, and then it takes a couple of minutes maybe. Okay, now so I'll give the names like Cyclone 3, yes, and then I create case. Now in initial we have to import the geometry before we make it mesh, because we want to make a mesh that form as a cyclone geometry. So we need the STL file as an object, as a geometry. So we now import from the here. I just make it. I just download from, and here we got 4 STL files. STL will form a closed region of a cyclone like this. And then before that, let we check the dimensions of the cyclones. So the unit is a meter, and it doesn't make sense that the cyclone's geometry is 55 meters. It's so big. So it means that we have to scale the geometry first. So I click here, and then I right click, and then I scale, and I put down 1a minus 3, and so on the others file STL. I scale it there, and 1e, sorry, like this. I'm turned into millimeters, so I scale it to 0.001 or 1a minus 3 like this. And don't forget to uniform scaling, scales, and the last is here inlet. I also scale, uniform scaling, and 1e minus 3. So now the geometry is gone, but it's not gone. It's actually just scaled to be smaller size. So just click here. This is the scaled one. So now after we scale, we check the mesh using auto size dimensions. Okay, now this is more makes sense. It makes sense right now. So just click in whenever you want here, or you're here, and just click enter, push enter button, and then see the best mesh here. And then we have to consider the number of mesh that can make appropriate cell size. So we have to make it that the cell size should be proper. So I mean the proper size is like the size in here, and the horizontal and the vertical should be proportional. It should be like square. Yes. So I mean here it's not seems to be so proportional because the ratio between the horizontal and the vertical is still somewhat um, like not square, but it's like what is that? Yeah, like that. So we have to make it more proportional. We have to make the ratio between the x and the y is more proper. So I think I just want to make it like, for example, here we just I'm going to make it for reference number 20. We look at this in the coordinates. The x here, the y is vertical, z into this. So if I make it 2020, okay, in the top here, the cell size is, I think it's good. It's quite enough. It's good. While here, I think it should take more number of cells in the y direction. So I think I will make it maybe just 40 or 60 maybe. Yes, 60 is good enough. Okay, yes, nice. So now the next step is we have to make a refinement in the wall, or let us create the mesh first and just generate mesh, and of course we have to put down the reference point. The reference point is because the simulation will be simulated inside the cyclone separators, or the the fluid domain is inside the separator, cyclone separator, not outside the separator. So we have to put the reference points inside the separators, inside the cyclone's geometry. So for example, if we put down 0, 0, 0, if we click in this button, so it will appears the yellow point like this. But this is not good because the yellow point is located outside the cyclone geometry. So we should put into the inside of the cyclone geometry. So I think just maybe how about I put down here 0.1 and 0.02 and 0.02 like this. And yes, here we got the point now is inside cyclone geometry. Now the next step is we just create mesh, generate mesh like this. So the meshing process is quite fast, but I'm afraid the result will not so good enough. So we see how the mesh will be formed. Now, okay, now I think the mesh is not good enough because see the nuts is still very coarse. I think how if we make some refinement. I think I want to refine the mesh in the wall area. So in wall area, you can geometry mesh and you click down here, and then you set the surface refinement into 1, or just I want to set minimum level to be 1, so the maximum level will be automatically changed. And also the edge refinements I put down here to be 1. I make it to be 1 here. And now let's regenerate the mesh. And how does it will be look like? So because the process is quite long, I think I just want to skip this and pause the video. Okay, now the meshing process is finished. Now we see that the mesh is turned into better. So yeah, it still contains several limitations, but I think it's better than the previous mesh. So now let's check the mesh, and I think the mesh is okay now. Now we go to the simulation models, and then in this case simulation we use LS, we use LS and transients of course, and then we put we check the gravity. So we want to activate the gravity of course, and then because this simulations is multi phase consists of fluid and particles, we use the multiphase Euler Lagrange like this. And then we don't forget to scroll down here and apply model. So don't forget to apply model. And in turbulence, I think we just changed here the turbulence filter from simple into anisotropics, and now we move to the discrete phase. Discrete phase, I think here we don't make any change here. Just let it the default. And injections, we use the boundary injections. Then I think I will not make any change for this, but I think I just want to make change in here. I turn the parcel per second from 1,000 into 10,000s, and I just made the durations of injection from 10 seconds into 3 seconds. And the locations where the particles injected is of course not from the wall, is from the inlet. From the inlet, and I'll make initial velocity of the particles maybe not so fast, maybe just about look at here in inlet here. We see that the particles, if we want to make the particles float inside for cyclone separators, it is the direction is minus z. For example, here minus z, right? Minus z directions, because here in the left here is minus z, so I make it minus z. So it's just u, y, and z x velocity direction. I make it minus 0.3, for example, and after that I make a distribution. Distribution is we don't make any change here, so let's go to the models. Here the models is in the drag particle models I change into spare drag, and I think there is no others things that we have to make change in this page, so we move to the solutions. So here I in the averaging I make it into dual, right? Dual, and nothing changed, so just here from here to dual, and no, there is nothing we can we have to make change except this. So now after that we go to fluid properties. I think I'll make it the default, because we use air as the default fluid, so let them to be the default. So now the boundary conditions I change. So now here wall is wall, of course, and the inlet, how about the inlet? So the inlet is the wall. The inlet should be changed the phase type to be patch, yes, because the fluid will go into here, and we change from the pressure inlet into velocity inlet here. And I think I'll make, for example, I give the 5 meters per second, that is fluid flowing inside from this inlet surface. I'll make it 5 meters per second, and of course particles. Okay, now we go to the outlet particles. I think because even though the name is outlet, I think we don't need make any change here, so let it make it to be wall. And after that we go to the outlet fluid, outlet gas. Inside here we change from the wall into patch, because the fluid will go outside through this top of the cyclone. So I'll make it not pressure inlet but outflow. Yes, okay, now it's perfect. So I think it is, we have finished set the simulations. Now we go to CFDSOF and then run solver, and I think I'll make change to the time steps to 0.001, and I'll simulate from 0 second to 5 second, for example, and change the data rate controls. I make it simulation times to be 0.1, so this software will save the simulation result for each 0.1 times step, or 0.1 run times. So now we finished the simulation. We got run solver, and that was how it works. So because once again, because the simulation is quite a bit long, it requires a long time to simulate, to finish the simulation. I think I'll just skip this to, until, so I'll not continue this video until the finish. So because I give you the result in the initial video, so That's it's how we make a simulation. We do cyclone separator simulations. So have a good trying. Have a nice day to try the simulation, and bye bye. Assalamualaikum warahmatullahi wabarakatuh. Wow, it's very good. Stop solver. Okay, now I think the next step is